All right, Twitch, how's it going? So we're back with our, sorry, I'm just trying to find the right page in my browser there. We're back with our series where we're looking at building a Kubernetes cluster on DigitalOcean using Terraform and Packer. Probably helps if I remember to get my microphone as well, right? So a quick recap on what we did last time. So last time we looked at building a very basic Terraform configuration, which looks something like this. So we're using the DigitalOcean provider. We're creating a resource. I'm going to change the name of that, actually. It should be K8. We set the image and some of the other stuff like the region and stuff like that. We load our SSH key, which we'd already configured in DigitalOcean, and we set the output. So what that does is that's going to create us a DigitalOcean droplet using the defined image here. Now, what we need to be able to do to get Kubernetes up and running is we need to build this image. So we started to take a look at Packer. And we started to build out some of this Packer configuration here. And Packer configuration is JSON based. So we started to define our builders. And we said that we want to use DigitalOcean builder. Our base image is going to be Ubuntu 14.04 64-bit version. We're going to put it into the London region. The size is just a small droplet at the moment, 512 megabytes. And we're setting the SSH username. Now what that'll do is that will create us the base image, but for it to be really useful, what we need to do is we need to install some stuff onto there, which is where this provisioner step comes in. So we're using shell type provisioner, and what I'm planning on doing maybe next week is working on this series a little bit further, and rather than using the shell-based provisioner, we can start looking at some Ansible, and hopefully we're going to get somebody from DigitalOcean to join us on that. But for the time being, the shell script will serve okay for now. And that shell script looks like this. So our first step is to install Docker. So to install Docker, we've got to add a few different bits and pieces, update our CA certificate and add the HTTPS app transport. We need to add curl and some other bits. Then what we do is add the Docker apt registry. And finally, we can install Docker CE, which is pretty cool. So how does that all put together? So I'm going to do a quick recap before we dive in and start expanding on that. So before we run the Terraform, we need to be able to create this image. So if you remember from last time, to create the image, what we do is packer build. And we're going to give it the template. So it's packer build k8.json. So that's now going to go away and it's going to create our droplet. So instead, let's have a quick look over here and look at our droplets, and you can see that Packer has now spun up our droplet. So what Packer's doing is Packer's going to start a droplet in DigitalOcean. It's then going to run our provisioner script. So we can see that started. Back to the Packer window. So Packer's now waiting for the SSH to come online. And once that's happened, which it has, you can start to see that it's running through the provisioning steps. And it's starting to set up all of that sort of stuff there now. So installing apt update, adding the registry, and it'll now go ahead and install Docker. Takes a little while. While that's going, I'm going to tell you about London. London doesn't get a lot of snow, and we've had snow. And I'm surprised the internet's working and I can be able to do this, because literally it is a national disaster when you get snow in London. The 3 days you get every decade or so, it seems to grind the whole city to a halt. We're just not geared up for it at all. But it's fine, because I work from home, so I haven't had to travel, which means I can do this, which is epic. All right, so that snapshot is, we're just snapshotting that image. All of the stuff's been installed on the droplet. If I go back to my, yeah, exactly. And you totally can't ski in London. There's not enough hills. We can see that that's going to run, and what it's going to do is it's going to snapshot that droplet, and it's going to create a volume that we can reuse. And that just takes a little while. It's got to sort of run through that process. And we'll just wait for that. Come on. I tell you, it always takes 30 times longer when you're staring at the screen waiting for it. But that's created now anyway, and that's pretty quick. So what we have is a snapshot ID that we can now use to spin up, to start another droplet. So if we go over to our Terraform configuration, I can add that image ID into my Terraform config. I can now do Terraform, well, I could do Terraform plan, but I renamed this to K8. So that's what it's telling me there. This is interpolation syntax. So I'm basically linking to the IPv4 address that comes from my resource after it's created. So I do Terraform plan. I can see that it's going to create me one resource. I then do my Terraform apply, and it'll go ahead and it'll create that based on the image that I've just generated with Packer in DigitalOcean. So again, if I just refresh that, you'll see now I have a volume, which is my snapshot that I've just generated in Packer. Well, oh, sorry, it's an image, my bad. There we go, once it loads. Twitch streaming seems to kill my bandwidth. So there we go. This I just created 3 minutes ago. I'm now spinning up a droplet which has come up, and you can see that Terraform has output me the IP address of that droplet. So I can do SSH root at the IP address. I want to say yes. Just unlock my SSH key, and that'll log me into the machine. There we go. So that's logged in now. I can do Docker PS, and you can see that Docker has been installed. So the next step is to go through, we need to install kubadmin and a few other bits and pieces, and then we can bootstrap ourselves a single node Kubernetes cluster, which is the next bit of the plan. So first things first, I'm going to quit that. In the same way as I can do Terraform plan and apply, I can also do Terraform Destroy. It's telling me that it's going to destroy one resource, which is my K8's droplet. And what will happen over here, you'll start to see that that'll terminate. So I've automated the entire process of creating this droplet inside of DigitalOcean using Terraform, and also I've destroyed it as well, all just using Terraform, so no interaction with the DigitalOcean API. Directly with the DigitalOcean API. So let's take a look, right? So our next step. So I've never really done this before. I'm going to go through and I'm going to try and find the right bit of the documentation which tells me how to install using kubeadmin. So you have to just bear with me one moment. I know it's in this doc somewhere. I don't want to use Minikube. I don't want an interactive tutorial. Services, clusters. Oh, come on. Maybe it's not in the tutorial. Cube control. Setup. I will find it. I know you're in here, documentation. Bootstrapping clusters with kubeadmin. All right, excellent. This is what I want. So this tutorial is actually really good. It actually tells you pretty much everything you need in terms of going through and setting up Docker and stuff like that. So the next thing I need to do is, because we've already got Docker bootstrapped, is, hey Eddie from DigitalOcean in the house. The next thing we're going to do is install kubeadmin, kubelet, and kube control. And this is really difficult on Ubuntu. Yeah, I got to do some cut and pasting. Like, I so much love things that the hardest piece of the work is cutting and pasting. So I'm going to copy all of those and I'm going to put those into my install script. Right, so we got Docker installed. Echo, let's do install K8s. So again, we don't need that step because we've already installed the transport and we've already updated apt. We do need to add the Kubernetes repository, and then we're going to do apt-get install. We're going to install kubelet, kubeadmin, and kube control. What is this session about? So what we're doing in this session is we're doing part 2 of the session where we're building a Kubernetes cluster on DigitalOcean using HashiCorp's Packer and Terraform. Right. So then once that's installed, the next thing to do is we can use kubeadmin to create a cluster. So initializing the master. So the concept behind Kubernetes is you have the concept of masters and followers, or, well, servants, whatever the sort of the term is. But to create the master, what we do is we run a very simple command, kubeadmin init. And this will go ahead and this will bootstrap everything I need and will start the server and get everything up and running. So let's do that, and then we can talk about that whilst I'm running my Packer build, and we can go through the next steps. So kubeadmin init. So again, I'm going to do my Packer build k8s.json. Packer's going to go. It's going to create my workers. Yes, yeah, that's right, the term. I can never remember. They're called so many different things in just about every bit of distributed software, but master and workers. So Packer is again going to go and create us a droplet, and it's going to start to run our provisioning script, just like we did before. So while I do that, what I'm actually going to do is, to make it a little bit less confusing when we're looking at these images, I'm going to delete these old snapshots that I've got. Oh, hey, Oscar. I see you're there. Okay, so I'm deleting those. So it just takes a little while. Again, Packer's got to spin up the droplet. It's got to wait for it to come online, and then it's got to go through the things. So kubeadmin will set up our sort of very, very basic single cluster for us. And then what we'll be able to do is we'll be able to retrieve the Kubernetes config, and we'll be able to start interacting with it. And that's a pretty quick thing to do and to get going. So once that comes online, won't be long. So one of the things that we're going to not do is we're not going to expose the kube control panel, the control plane for Kubernetes, to the public. So we want that all locked away behind a firewall. And the reason for that is, if you do a little bit of Googling, there was a recent incident where I can't remember the name of the company. It might have been Tesla, or somebody who's really high profile. And I think it was a Bitcoin miner or something like that, found their Kubernetes control panel and decided to use their resources to mine some Bitcoins. Very easily done. So I think the best approach is to take a policy of no trust and open up access as and when you need it. But you really don't need public internet access on your Kubernetes API. We can get access to that in a number of ways, and one of the ways I'm going to do it is I'm going to use an SSH tunnel. So we'll have a quick look at just how we can do that. As soon as this spins up, that is. There we go. So that's installing Docker, and then it's going to go through and it's going to install Kubernetes. So while we're waiting for this, let's have a look at an SSH tunnel. So what does an SSH tunnel allow us to do? So an SSH tunnel allows us to map a local port on our laptop, and we can map that to a remote port on a server. And what's happening is, whenever you send a message to the local port, it's actually sending that traffic over an encrypted SSH connection. So you're using the same SSH key that you would use to log into the server, but you're just sending this data direct over, we're sending the packets over SSH. So we can basically create a secure connection between ourselves and the Kubernetes API. We can see now where we're up to on this Packer build. We are still going. Yeah, we're still waiting on this to go through. These things take a little bit of time, and probably doesn't make the greatest of viewing. I should have some kitten videos or something like that. But what this SSH tunnel is going to allow us to do is, it means we don't need to open up our Kubernetes control plane to the whole world over the internet, because you don't want to be a Bitcoin miner. Well, especially when you're not going to be getting the revenue from it. While that's going through, so what I'm going to do once that's been created, and once we've managed to get our Kubernetes credentials, and we've managed to log in against, and we can use kube control using our SSH tunnel, is I want to run a pod. And once we get to that sort of level, I'm going to start doing some stuff around showing you how you can create other resources in Terraform. So we're going to need to create a load balancer. So we'll have a look at some of the other resources that are available to us with the Terraform DigitalOcean provider, which allow us to do that in the same way as we can easily create our simple resource. So we've got a number of different things we can do. We can upload a certificate. So if you've got your own SSL certificates, you can add those, which can then be added to the load balancer. We can control the DigitalOcean firewall. So we can specify the inbound and outbound rules. So again, we don't want too much expose. We want to keep it to the very, very bare minimum. We can set the floating IPs. So if somebody's not familiar with the concept of floating IP in DigitalOcean, it means that you bind a floating IP to something like a DNS, and then you can assign it dynamically to your box. So you don't sort of have to worry that your TTL settings need to expire if you spin up or destroy a box. We can use these handy floating IPs. And DigitalOcean also has a load balancer. And what we can do with the load balancer is we can point it at a number of resources. So this is probably going to be the next thing we look at once that Kubernetes stuff is installed. And we're still waiting on that to go. So DNS records, if you're sort of using DigitalOcean as for your DNS settings, you can use these resources. Again, the SSH key, this allows you to sort of manage your SSH keys. So actually, why don't I add that now while we're waiting for this packet, and I can show you how we can add more resources. Okay, so back to our Terraform config. So our very, very basic Terraform config. Here we have an SSH key, and this SSH key is something which already exists inside of DigitalOcean. But I want to actually be able to provision everything using Terraform. I want everything infrastructure as code. So what I can do is I can add this resource, and then I can add a new SSH key to DigitalOcean. So let me show you how simple that is. So what am I going to call it? I'm going to call it K8 cluster, because it's good to have different keys rather than sort of having one God key just in case it does leak somehow. And then we specify the public key, and the public key is the contents of the file. So what I'm doing here is I'm using this interpolation syntax. So interpolation syntax it's kind of links. I'm trying to think of a simple way to explain it, but if you could think of it as like links and functions. So rather than just text, I can execute this file, which is a function, and what that will do is that will load the contents of the file. Because I'm using the interpolation syntax, Terraform is going to replace the contents of this dollar curly bracket. I think this is called dirty money, if I'm right, dirty money syntax. I'm sure that's what the Terraform community has named it. But it'll replace that with the contents of this file. So I'll actually be making a call to the DigitalOcean API under the hood to create a key with the name of K8's cluster and the contents of this file, which of course is not correct because I don't have that folder. So what's useful is I can show you now how to create some variables, because we should be making this dynamic. We shouldn't really have things like this hard-coded into our config. So let's add a variable. And I don't want to add it there. Thank you, Vin. So a variable in Terraform, if you think of it as an input, so it allows you to provide inputs to your Terraform configuration, and you can use file-based inputs, you can use environment variables, you can pass it as flags to the Terraform plan and apply command line, or a number of different ways to do that. And it uses very, very simple syntax. So it's variable and then the name of the variable. So in this case, it's going to be SSH public key. And I can provide a default or a description as well. So I'm going to say description. And I'm going to say, whoops, SSH public key to add to droplets. And I will provide a default just for convenience here. So I'm going to SSH folder, and id rsa.pub is my main public key. So now I've got that variable defined, I can actually start to use it. So rather than having a hard-coded value instead of file, again, I can use interpolation, and I can say var.ssh public key, and I've now got something which is nice and dynamic. So now this DigitalOcean SSH key resource is going to be dynamically created based on the file path in my variable here. But I also want to add that to my SSH keys bit. And how are we doing with our build here? Well, we're still going on that. So let's have a look again at this Terraform resource config. So name. What is name in a resource? Name is an argument. So arguments are inputs into resource and data elements. To get something which is usable on this public key, I actually need the fingerprint. So that is this, this sort of sequence of numbers here. So once that's dynamically created, I can actually use the attributes. So attributes are outputs from a resource. And I can get the fingerprint. So let me quickly show you how I can use that here. So inside my list of SSH keys, because I don't know what that fingerprint is, again, I can use interpolation. So I can do resource dot DigitalOcean.ssh key, and then it was fingerprint. Sorry, my bad. Okay. So why is this good? So this is good for two things. And the first reason why this is good is that I no longer need to hard code the SSH key. But there's another important reason, that when I'm using the interpolation like this, what it means is I'm giving a hint to Terraform that this resource, this DigitalOcean SSH key, has to exist before I can populate this SSH key. So in terms of the way that Terraform will do that is it's going to build a graph. It's going to build a dependency graph. And it's going to ensure within that dependency graph that the DigitalOcean SSH key resource exists before it attempts to create the DigitalOcean droplet. And that's really useful because for us, it just means we run Terraform plan and Terraform apply. We can forget about any form of order. If I change the droplet, Terraform's automatically going to figure out whether the SSH key already exists. And of course, when I come to destroy it, it's going to do exactly the same thing in reverse and make sure that it destroys things in the correct order as well. What's going on with this? No valid open PGP data found. Our installation seems to have frozen. We're going to, we'll give this a boot in a second. All right, let's have a look at our Packer script and see why this is not working. So the following new packages will be installed. 8 newly installed. Install K8, download Docker, blah. Unable to connect apt.kubernetes. Network is unreachable. I wonder if we're having some issues with that. I'm going to run it again. So kubadmin. Packer build case.json. What application I'm building? I'm building a Kubernetes cluster on DigitalOcean with using Terraform and Packer. So it's 100% automatable. So it means that we can redeploy it as a staging environment, production environment. We're taking an immutable approach to our infrastructure. Once we've got this all set up, we can be very, very confident that we can recreate exactly the same environment time and time again. Yeah, automation. But the benefits of doing it this way is you've got this infrastructure as code. So everything is declarative. You can kind of read and see what's going on. It's reproducible, but it's a little bit cleaner than sort of doing it if you were just using bash scripts or something a little bit less sophisticated. Unmet dependencies. Some packages cannot be installed. Right, I'll tell you what I'm going to do. Let's debug this. So what we're going to do in our script is I'm just going to temporarily remove the install Kubernetes. I'm going to create a Packer image, and then we can go through and we can find out exactly why it's not liking this. I'm using Xennial there, but I'm pretty sure my image is based on 1404, which it is, and that's not Xennial, is it? I'll tell you what we can do. Why don't we update to Ubuntu 16? So if I can go and create, I'm just going to grab the name of a droplet. So it's 1604.3x64. So I'm going to modify my Packer 1604 x64. And while I'm here, actually, I think I will create a slightly beefier image. Control manager. So this is kubeadmin init is running. We're now installing Kubernetes 193. So this will take just a little bit. And as it says it might take a little bit longer because it has to pull those images into our local Docker. So that there we go. We've got our Kubernetes master. It's initialized successfully. To start using your cluster, you can run following as a regular user, blah, blah, blah. So let's just quickly, I'm just going to copy that. So once we've got that snapshot completed, then we're going to spin up our incident. So Eddie, I believe you and I are going to be doing some Twitch streaming next week where we're gonna teach the world how to use Ansible, right? We're totally doing that. Whether Eddie likes that or not, we got to do that. We've got our droplet. So I'm going to grab the ID of that. And what I'm going to do is I'm going to modify and I'm going to add a variable again to my Terraform config. So variable, I'm going to call it image ID. Description is going to be image ID. And then in my Terraform config, again, rather than hard referencing the image, interpolation syntax, var dot image ID. The size, so I'm using for a slightly beefier box this time. So again, I could put that into my configuration in my variables file. I'll do that just a little bit later. But let's spin up that box. Let's have a look. Unknown resource, DigitalOcean SSH key. Resource, DigitalOcean SSH key. Oh, of course. So let's have a look at what we're doing wrong here. So when you're using interpolation syntax, you follow a three-part referencing. So you don't need resource in front of it. You have the name, the type of the resource, in this instance, the DigitalOcean SSH key. You have the name of the resource. So we've just called this one default. And then you have the attribute that you want to reference. So I got it right down here, but I made a fat finger mistake up there. So that's going to create me two resources, the droplet and the SSH key. Again, you can see just in the output there that it's got the contents of my public key. And what error have we got? So the SSH key is already in use in your account, which of course it is because I've added it previously. So let me go into my DigitalOcean account and I'm going to dump this into secure mode just in case I leak my API credentials. Oh, it's an API. No, that's my personal access tokens. Where is the SSH key? Security. Oh, there we go. So it's in security. I can show you this. So I've already got this SSH key in here. It's matching it out on the fingerprint, so I'm just going to delete it. And then again, I'll run my Terraform apply, and this time it's going to go ahead and it's going to create everything for me because it doesn't exist now, which is handy. So that will take just a couple of minutes. I think it was taking like about a whole 25 seconds to create a VM based on our image in DigitalOcean, which is just, it's terrible. We need to, Packer absolutely needs a Tetris mode while it's running. Or what I also recommend is that you plug a Nintendo Switch into your monitor and you just flip and play a couple of games of Mario Kart or something like that. So that's up and running. So let's log into that. Yeah, all right. So then we've got everything running. kubectl. So kube control is installed. What is it? List all or something? Yeah, maybe I do mean get. Error, cron job matches. I'm a total noob when it comes to using kube control. Let's see if we can get some of the where? Let's have a look. Cluster info. Excellent. So you can see that down the bottom there. 100%. We could have Pong. There's all sorts of great vintage games. That could even be a plugin. There could be a market for this. So we've got the master. It's running all there. So what we want to do now is get access to that the control plane in the web browser. So theoretically, let's have a look. Blah, blah, blah. What we need to do is we need to get our Kubernetes config. Right. So I can create, why don't I create a little bash script which just downloads the Kubernetes config so that we can, it'll be easier for us to use it locally. And I can check that into the repo. I could actually run that as a post exec strip, but yeah, not to worry, later. All right, so add, we're going to call it get k8 config.sh. So to get our Kubernetes config, if you don't already have this, so what we're going to do is we are going to copy it, but well, we can't get it from the local disk because it doesn't exist. But what I can do is I can SCP it. So if I do SCP root at, and if you remember from last week And if not, there's a handy little trick that we can do with Terraform output. Because if I do Terraform output as a command line, I can see all of the output variables which I've defined in my Terraform config. So there we go, that's an output variable. But what I can also do is I can reference it by name, and it'll just return me the string. So when it comes to doing something handy in this bash script, I can actually just use a subshell and do Terraform output, was it web IP? Yeah, web IP, etc. Kubernetes admin.conf, and we want to dump it in home kube config. And I don't need to change the owner of it because that'll happen with SCP. So let's see, /chmod plus x get our Kubernetes config. So we've now got our kube config, and I do have kube control installed, which is relatively handy. So the next thing to do is to start that SSH tunnel. So I want to start an SSH tunnel from my local server, and I want to point it at this remote box. So back over here. So basically, this is the syntax. So we're going to do SSH. We're going to specify the name of the server. We're going to specify the local port, which is 2000 in this example. And then I want to bind the local port 2000 to this server port 25. So I'm going to do exactly the same thing with my kube control. So let's add that to the README. So again, so we know we're creating our user as root. We don't have an IP address. Well, we do, but we can use our subshell to get that. So it's going to be Terraform output web IP. The local port, I'm probably going to have something running on 8080 already, so I'm just going to use 9999 for the time being. And I want to tunnel it to 8080. So that should give us a remote tunnel to the Kubernetes API running in our droplet. So let's have a quick look at that. Kubernetes master is running there. Let's have a quick look. kubectl. I don't know, did I? So Kubernetes is definitely up and running there. We've got the API running. Cluster info. Did you specify the right host or port? netcat. Is it? Oh, I can never remember. No, not netcat. I'm trying to remember the bash command to list a whole bunch of ports. And of course, I'm never going to be able to do it. So I'm just going to have to Google it. And we can work out why that's not working. Netstat. Damn it. So we got Docker, we got that, interface table. And there is actually nothing running on port 8080. So our Kubernetes API server is running on 6443. Oh, how do you start the admin interface? Never mind. Let's get this running first. Cool. So my SSH tunnel. So now we can see that the Kubernetes master is running at the IP address there. So we've created an SSH tunnel to our remote droplet running up here. And if I add dump into that. So this is the cluster that information that we've downloaded. What we've managed to do is we've now got our Packer build, which is creating and installing Kubernetes using kubeadmin, and all of that is up and running. We've got our Terraform configuration, which is loading our DigitalOcean SSH key. Our SSH key for DigitalOcean. We're creating a droplet based on our Packer image, and that's looking pretty good. I mean, the next thing to do really is, once we've had a little bit exploration on this a little bit further, is we can start creating some more droplets, and then we can start clustering them together, which is going to be very cool, I think. All right, I've had to do a little bit of digging into this because we couldn't quite work out why it wasn't allowing me to connect. And the reason that it wouldn't allow me to connect was because in my Packer file, I was actually initting Kubernetes. And the problem with that is that it sets everything up and it'll bind it to the local IP of the droplet. Well, the IP of the droplet is going to change when I restore the image. So I can't set up kubeinit inside my Packer config. But that's fine. So let me spin up a server, and I'll show you how I'm doing it now. So quickly Terraform apply, and that's going to run away. So what I've done is so firstly I've changed my setup here. So I've removed Kubernetes init, but I still need to call init. So what I'm doing inside of Terraform is Terraform allows me to use these concepts of a provisioner. So what will happen is after a resource has been created, the provisioner will run. And the provisioner that I'm running here is a remote exec provisioner, which means that it's going to run this script here over SSH using the root user, which is what I'm setting up in my droplet. So the command that I'm using is pretty much the same command that I originally had in my Packer build. So I'm just running kubadmin init, but the difference is that this time I'm running API server advertise address, and I'm setting that to the private address of the Kubernetes master, which is going to be the droplet's private IP. To enable the private IP, I also have to set the private networking flag in my resource for that DigitalOcean droplet. And once I've done everything there, everything seems to work out just great. So that's just spinning up. It won't take a great deal of time. And then we can give that a whirl. So while that is spinning up, there was a couple of things which I needed to do. So if I want to SSH into my server and then run any kube control commands, then that's absolutely fine. I can do that. So let me just log into that machine. So I'm just logging into that server now. I need to set my kube config, and for the life of me I can't remember. So export. Can't quite remember what the location is. Give me 1 second and I will dig that out. Where is that? Etc. Kubernetes admin.conf. So once I've set my kube config, then I can do kube control get nodes. kubectl. And you can see there that I've got one Kubernetes master, so that's everything's working. Now, if I want to run that from my local machine, as I was sort of explaining earlier, we're going to use an SSH tunnel. So the first thing I need to do though is I need to go and grab that Kubernetes config. So I've just created a little bash file, and what that does is that goes and it'll just fetch that file using SCP from the remote server. But to use it, I've got to do a couple of extra little bits and pieces. So what I need to do is I need to set the server. So if I look at that file as it's downloaded, I think I call it DO. You'll see that the server, sorry, I've already changed it. So the server here would have the IP address, the private IP address of the machine. So when I run kube control, it's going to try and connect to that private IP address, which doesn't exist. So to enable an SSH connection over to use kube control, what I'm going to do is I start my SSH tunnel. So my SSH tunnel, and I'm going to tunnel to my remote server, the Kubernetes master. I want to map 6443 on my local machine to the port 6443 on the remote machine. So I can just run that and that'll connect. Now, what's going to happen is when I do kubectl get nodes, so Kubernetes kube control is going to look at this field here, this server field, to try and use that to connect up to the Kubernetes API. But obviously this is a local address. So the reason that I had to put this local address in is if I look in my etc hosts, I've put the Kubernetes address in there. And the reason that I did that is because if I don't, and I just try and connect to localhost, what's going to happen is I'm going to get an error message where Kubernetes is telling me that the address localhost isn't in the X509 certificate. So it's not in the certificate that was used to bootstrap the cluster. So there's a couple of things I can do around that. I can actually add my own names into that certificate, but it makes the configuration a little bit more complicated. So this is a fairly simple workaround for now. And as you can see, if I do get nodes, then everything is all working. Can I do get pods? No pods running there, which makes sense. And that's enough to get things up and running right now. We could SSH into the machine if we want to, but if we do want to run kube control locally, then this little workaround with an SSH tunnel works just fine. And then next time we can get this all clustering. So until then, I'll see you all later.